Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we will be going over Ottocento number 1, percents. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so the first skill we're going to talk about is percent of. So what you do when you see a percent of is you change the percent to a decimal. To do that, you divide the percent by 100. Next, we change the word of to a multiplication symbol. So, for example, let's say we have 45% of 260. We divide by 100, so 45 divided by 100, and we change the of to a multiplication sign. 45 divided by 100 is 0.45. And now 0.45 times 260 is 117. So you could just type the second line or even the first line up at the board, up on Desmos, but I highly recommend you know how to do this by hand because you're going to have to practice changing percents to decimals and of to multiplication for harder, more complex questions. Let's do some more examples at the board. All right, so the first problem we have is 60% of 240. So I'm going to divide by 100, change the of to multiplication, and keep everything else the same. So 60 divided by 100, you can use a calculator to assist you, especially if the numbers are really messy, is 0.6. And let's see, 0.6 times 240 is 144. So that's our answer for that one. I want to point out that, once again, we can do most to all of this on Desmos. So let's do the second one with the calculator helping us a little bit more. So we're going to do 325% of 84. So 325, going to divide by 100. And I'm going to change the of to multiplication. So let's try that. 325 over 100 times 84. And I get 273. I want to point out, as I said in my Desmos video on percents, you could just type in 325% and then of will automatically come up. Type in 84. However, you might come across symbolic problems. We're going to do one in a minute where you might not be able to rely on that as much. So I highly recommend you remember, okay, divide by 100, change the of to multiplication. All right, let's do some more. What else do we have here? Okay, out of 500 muffins, 75% contained nuts. How many of the muffins had nuts? So we're going to do, this question's essentially asking us 75% of 500. 75% of those 500 muffins have nuts. So we're going to do 75 divided by 100 times 500. And that should give us 375. All right, next one. So this is kind of what I was talking about, where you might get word problems where this one you could just type in a Desmos, but you're going to want to practice being able to do this with symbols for the test. So f of x is 30% of x. So I'm going to do 30 divided by 100, change the of to multiplication. 30 divided by 100 is 0.3. So we can rewrite this expression as 0.3x. You can imagine for a longer problem, that might be really important that you know how to do that. Okay, I think there's one more here. So it says the width of a rectangle is 80% of its length. So we have to do some words to math here. So the width, we can call that W, that is equals, and then 80% of its length. So 80% of its length, let's call that L. So 80% of L. So that's 80 divided by 100, change the of to multiplication, times L. So W is equal to 80 divided by 100 is 0.8. So that's one equation. And they also tell us the perimeter of the rectangle is 72 feet. So this actually isn't on the reference sheet, so you might want to know this. The perimeter of a rectangle is 2L plus 2W. So if the perimeter is 72, we can put 72 in for P. And we have this, and now this is now a system of equations. So what we're going to do is we're going to substitute this guy in for W. So he's going to go over there. And we get 72 equals 2L plus 2W is 0.8L. So 2 times 0.8, you can do this on a calculator. 72 equals 2L plus 1.6L. So that should give us 2 plus 1.6 is 3.6L. And now we're going to divide both sides by 3.6. And we get the L, the length, is 20 feet. And if you wanted to, as always with any time you substitute, if you want to go back and plug this in over here to find W, why don't we do that? So 0.8 times 20 is 16. So the width is 16 feet, and the length is 20 feet. And you can go back and plug that back in to check. 2 times 16 plus 2 times 20, I get 72. And is the width 80% of the length? 0.8 times 20, I get 16. Looks like we did a good job. So don't get too reliant on Desmos. Make sure you know how to write this out as an equation, because you might have to do that as part of a longer problem, as we just did here. Let's move on to the next skill. Okay, so skill number 2 is fractions / decimals to percents. I don't even know if I needed to make a slide for this, but I just wanted to quickly mention this. So first, you write your fraction / decimal. Then, to go back to a percent, you multiply by 100 instead of dividing by 100. So in this example, we've got 5 red shirts out of 16 total. What percent of shirts are red? So the fraction is part over whole. So 5 over 16, which if we put that in a calculator, we get 0.3125. Now to change it to a percent, you have to remember to multiply either the fraction or the decimal by 100. Since this decimal kind of ends nicely, it terminates, I'll stick with the decimal. So 0.3125 times 100, and I get 31.25%. Let's do a couple examples at the board. Okay, so for this first one, we've got 28 red marbles out of a total of 400. So our fraction is going to be 28 over 400. So I'm going to put that in a calculator. And since it came out nicely to 0.07, I'm going to use that. And to change it to a percent, we're going to do 0.07 times 100. So we write our decimal and then we multiply it by 100. So for this one, I get 7% are red. Great, let's keep going. All right, so this table on the bottom here. First off, when you see a table and a problem like this, you're going to want to add like a total row if there isn't one already, or at least write it down on your scratch paper. So here, we're going to add all those up, 4 plus 8 plus 6 plus 2, and we get 20. So what fraction of the shirts are red? So red would be 4 out of a possible of 20. So we're going to do 4 over 20. And we can write that as 4 over 20 is fine, but we could write it as 1/5, which is the simplified fraction, or because the decimal comes out nicely, it wouldn't be the worst thing to write the decimal. We could put it as 0.2. Either of those would have been fine. Great. Okay, so let's look at the next one. What percentage of shirts are green? So, and why don't I do it kind of all in one go this time? So, so green. So we're going to do 2 out of a possible of 20. And because we want a percentage, we're going to multiply by 100. So let's see what that gives us. So 2 over 20 times 100. And I get 10%. So 10% of the shirts are green. Very good. Let's move on to the next skill. Okay, so skill number 3 is proportions for percent problems. So you might find that when you're doing like more convoluted problems than just a percent of, that knowing an equation might make it easier. So for words to math problems, you'll see what I mean by that in a minute. We use the equation is over of equals percent over 100. And for story problems, we tend to use the equation part over whole equals percent over 100. Now, remember what we were just doing, making the fraction into a percentage? That's something that they ask you to do on the SAT a lot. So I rewrote this as percent equals part over whole times 100, just because you'll see that question a lot on the test. They'll ask you, what percentage of these things are yellow or something? So maybe knowing both might save you a little bit of time. Whatever works for you. Let's go back to the board and do a couple examples. Okay, so this one, these ones at the top are, the first couple of these are words to math. You see how there's a lot of is's and ofs and percents? So we're going to use the equation is over of equals percent over 100. So right away, if there's a percent, I just identify that. I go, okay, whatever is glued to the percent symbol is the percent. So on the right side, I'm going to put P over 100. Okay, so now let's say is next to 25, so we'll put 25. And of is next to 200, so we'll put 200 where the of goes. And now anytime to solve these equations, you can cross multiply. So to cross multiply, we're going to do 25 times 100. And anytime if you want to use Desmos to help you, you can. 25 times 100 is 2500. 200 times P is 200P. So we're going to do 200P. And now we divide both sides by 200. And we get 12.5 equals P. And if you want, you can go back and plug that back in and see if it kind of makes sense. So 12.5% of 200. Okay. So that's 0.125 times 200, and I get 25. So it seems like we did a good job. Great. Let's look at this one. 43 is p% of 129. Okay. All right, same kind of deal. Always pick out the percent first. So I'm going to put p over 100 equals, next to is 43. And next to of is 129. So we can cross multiply. 4,300 equals 129p. And then we divide both sides by 129. And I get p equals 33.333. I think they say 5 or 6 characters. 1, 2, 3, 4, 5, 6. That should be right. Now, I want to point out to you guys that there's a common misconception that on the test, you have to write percents using a decimal. That's not true. You actually can put it in its fraction form. So I'm going to show you that right now. So let's get rid of all this. What was it? 4,300 over 129. If I simplify that, I get 100 over 3. So to me, so you could write p equals 100 over 3%. Now that looks really weird, but it is technically correct. And they've done questions like this before. And you might as well just let the calculator help you simplify, right? You might mess up on the rounding to 5 or 6 characters, whatever the weird rule on the SAT is, but you're not going to mess up the fraction because Desmos can help you get the fraction. So don't let that confuse you. You can absolutely write percents, a messy rational percent, as its fraction form. You can do that. Looks really weird, but it is right. Okay, let's look at this one over here. 45% of x is 180. Same deal. I'm going to do is over of equals percent over 100. And first thing I'm going to do is the percent. So the percent is glued to 45. Is next to 180. And of is next to x. So let's cross multiply. So we get 180 times 100, 18,000 equals 45x, 45 times x. Divide both sides by 45, and we should get x equals 400. Think that's right? Okay, let's look at this guy over here. Josie sold 39 out of 120 crafts. What percent did she sell? Okay, remember guys, part percent is equal to part over whole times 100. Okay, so we're going to do 39 out of a total of 120 times 100. And let's see what that gives us. We get 32.5%, something like that. Not doing any of this in my head, using the calculator, just making sure that I understand the steps of what I'm doing for when I get really tricky problems. Okay, I think this is our last one. So, whenever you see in terms of, the thing right before it, you just need to get by itself. It's called a literal equation. We'll have a video about that another time. So, same deal, is over of equals percent over 100. And okay, the percent is P. Next to is 27. And next to of is X. So now we want to get X by itself. So we're going to cross multiply. So 2700 equals P percent yeah, for whatever reason they write it like this. I'm going to write it like this. 27 times 100 equals X times P. So how about we just call that PX? So now to get X by itself, we're going to divide both sides by P, because the opposite of multiplication is division. And we get X is equal to 27 times 100 over P. And I'm pretty sure that is answer choice D. I think we did a good job there. So you see, like, especially if you come across a hard question like this, it makes it so much easier if you just have something to look at before you start doing the question. So lots of people don't like this, but I still think there's a lot of value in the is over of equals percent over 100 equation. It helps a lot. All right, let's move on to the next skill. Okay, skill number 4. This is one of probably the biggest takeaways from this video. So many students either forget or they just never learned how to do this. And there's other ways to solve percent problems like this, but the reality is the SAT is designed for you to do it this way. So you have to do it this way. So we have to find what's called a percent multiplier given a percent increase or percent decrease. The percent multiplier is just what number you're going to multiply a value by to get to apply a percent change. So to figure out the multiplier for a percent increase, what you do is you do 1 plus the decimal. So 1 plus percent divided by 100. And for a decrease, we do 1 minus the percent divided by 100. So 1 minus the decimal. Some key words that are associated with a percent increase that show up a lot on the test. So percent increase, percent greater, percent more. Now, some common like real life scenarios where this comes up on the test and just in general. Sales tax. So like when you go to buy something at the store, they put like a 5 or 7, 8% tax on top of it. You pay extra money to the government, so that's an increase on your bill. Similarly, if you go to a restaurant and you do a 20% tip, you're giving 20% extra for the waiter. So that is also a percent increase on your bill. Decrease. We see the words percent decrease. We see the words percent fewer, percent less, and this one really can trip people up. The real world scenario that you will see in the shopping problems is a discount or like a coupon. So oftentimes you'll see this worded in books and stuff using like 25% off. That's a 25% decrease. Don't confuse that with 25% of with one F. 2 F's is a discount. It means it's a percent decrease. So we'll get into how to use these in a minute. But before we do that, I would make sure you have this all down in your book. And then there's one other thing we got to do, which is this equation. So original, or your starting value, times all your percent multipliers in a row, however many you have, usually on the test it's just 1 or 2, equals final. Original times percent multipliers equals final. All right, let's go ahead and do some examples at the board. Okay, so before we start talking about what a multiplier is, let's just make sure we can calculate them. So once you have a handle on what you need to do, the calculator is incredibly helpful for figuring out the percent multiplier. I went over this in my Desmos video. You can check that out, but I'm going to go over it again here anyway. So 1 plus percent divided by 100. So for a 50% increase, we're going to do 1 plus 50 divided by 100. Now, if we go to the calculator, we can type it in just like that, and we get 1.5. I'm telling you. Do not do this in your head, no matter how simple it seems. Because if you do it in your head, you're going to forget how to do it. You're going to forget the mechanics of how to calculate it. And you are then going to come across harder numbers that you can't do in your head, and you're going to get it wrong. So please, please, please don't do this in your head. Use the calculator, even if it seems really simple, just so that you always remember how to compute it. So for this one, it's 1.5. All right, 80% decrease. We're going to do 1 minus 80 over 100. All right, let's go back over here. So 1 minus 80 over 100, that's 0.2. So the multiplier for that problem would be 0.2. Now, these bottom ones, much harder numbers, much harder to do in your head. So I'm not going to do it in my head. Increase. Okay, we're going to do 1 plus 357 over 100. Okay, let's see what that is. 1 plus 357 over 100. That's 4.57. So 4.57. Almost everyone would have said 3.57. Lots of people would have thought that. Okay, let's do one more here. So 0.4% decrease. See how tricky this is to do in your head when the numbers get really small or really really big? Sure, when it's like 10 or 20 or 50, it's not so bad, but when the numbers get bigger or smaller, it gets really hard to do. All right. So this would be 0.996. So maybe I would see that in one of the answer choices or something like that. Okay, great. So please, please, please make sure that you can do that. All right. What is the result of increasing? Okay, so when we're doing all these guys, just kind of keep in mind original. I'll write it again later, but original times percent multiplier equals final. Okay, so our original value is 150. So I'm going to do 150 times what we're going to do, a 190% increase. So let's figure out what that is. So 1 plus 190 over 100. That's 2.9. Okay, so we're going to do 150 times 2.9. And that should give us our final. So let's see what that is. I'll just do it over here. 150 times 2.9. And we get 435. Great, very good. Okay, let's keep going. Okay, Susie went to buy a $60 dress. A 8% sales tax was applied at checkout. How much did she pay at the register? Okay, so the amount she paid at the register, that's the final. So we're going to do original times the percent multipliers equals final. There's only one. And the original price is the sticker price, so $60. And we're going to do times the percent multipliers equals the final, which is what we want to find. So we could call that X if you want. So we have an 8% sales tax. That is an 8% increase. Remember we said sales tax is an increase. So let's see what the multiplier is. So we're going to do 1 plus 8 divided by 100. That's 1.08. So 1.08. And I don't need to do any algebra. Everything is like kind of where I want it. 60 times 1.08 is 64.8. And because it's in America, we would put, something in the hundredths place for cents. But that's never something they would test you on. This would probably be a multiple choice question. Great, very good. Okay, let's do the next one. All right, original times percent multipliers equals final. And the original is, they tell us, is $25. And we did a 30% off coupon. Remember we talked about that's a decrease. And we did a 6% sales tax. So that would be an increase. And now watch what I do, guys. The order you put them in doesn't matter. I'll just do both of them over here. So 30% off. Okay, 1 minus 30 over 100. And 6% sales tax. That's an increase. 1 plus 6 over 100. So the multipliers are 0.7 and 1.06. So watch what I do. I just put them next to each other. They just get multiplied one after the other. So many people, they would have tried to like added like 30 and 6 or like did negative 30 plus 6. That is wrong. Do not ever do that. See what I did with the percent multipliers? I found each multiplier and then put them one back to back. They are like totally separate. We don't combine them or anything like that. Okay, now I can go over here. 25 times 0.7 times 1.06. And you see, guys, it's really important that you do it like this because on a multiple choice question, they're going to write it using the percent multiplier. So if you do it a different way, you're not going to be able to tell the answer as easily. So please make sure you do multipliers. So I think it should be 18.55. At least that's what I got. All right, there's two more here. So this one here, same deal, original times percent multipliers equals final. Okay, so the original price, it says, what was the original price? So we don't know the original price, so we're going to put X. Now for the percent multipliers, we have a 35% off and a 7% sales tax. So let's find both of those. So 35% off, that's a decrease. 1 minus 35 divided by 100. And 7% sales tax, 1 plus 7 divided by 100. Great, so we get 0.65 and 1.07. So 0.65. And see how I'm not adding them or anything, I just put them right next to each other. And the final price is the amount he paid at the register, $50. So see how tricky that is? Many people, they would have put the 50 as the original price, but it's not. The 50 is the final price, and we want to find the original. So now you got to put your algebra cap on. All right. Well, we want to get x by itself. Those guys are being multiplied. Opposite of multiplication is division. So we're going to divide both these guys over. And I'm intentionally writing it like this because this is how the SAT will write it in the answer choices. So this guy goes away, and we're left with x equals 50 over 0.65 times 1.07. Very tricky. And you better believe there would have been a trap answer where you had to where like if you multiplied it, you get the trap answer. So very tricky. All right, 0.65, 1.07. Okay, and we round to the nearest hundredth, and we get 71.89. So it should be $71.89. So be very meticulous about writing down, okay, original times percent multipliers equals final. What's the original? What's the percent multipliers? What's the final? Sometimes they're not asking to find the final, they're asking to find the original. Okay, great. All right, let's look at this one. A quantity is decreased by 65% of its value. The resulting value is X. Okay, right away. Resulting value, that's like another word for final, right? So we're going to say the final is X. The original, we don't know. It wants us to find that. So you could introduce a letter. I'm just going to call it original because it doesn't matter to me. All right, and the percent multiplier decreased by 65%. I feel like even if, you could, for the most part, get this one right. One minus 65 divided by 100. Okay, so that's 0.35. So we're going to put 0.35. And right away, you can kind of see, oh, it's probably B, right? But, on the actual test, the trap answers might be more convincing. Okay, so to get the original by itself, we're going to divide both sides by 0.35. And we get original equals X over 0.35. But see, like, even if you don't know what to do, if you know how to calculate the multiplier on a multiple choice question like this, you can take a pretty solid educated guess, probably down to 2 answers, maybe even 1. So yeah, understanding how to compute multipliers is really darn important. All right, let's continue with the next skill. Okay, so skill number 5 is percent change from percent multipliers. So what we just did, where we took the percent change and found the percent multiplier, now we're going to do the opposite. You quite literally need to know how to do this forwards and backwards. So what you do is you take the percent multiplier, you subtract 1, and then multiply by 100. Subtract 1, and then multiply by 100. I summed this up in this nice little formula, but it's really better if you understand, okay, the distance from 1 is the change, subtract 1, and then to change it to a percent, just to change anything to a percent, you multiply by 100. So let's say we have a percent multiplier of 1.3. So we're going to do 1.3 minus 1. That gives us 0.3. 0.3 times 100 is 30%. It's a positive 30%. So we're going to say the percent change is a 30% increase. Let's say we had a percent multiplier of 0.75. So first we're going to do 0.75 minus 1. That gives us negative 0.25. Multiply by 100, we get negative 25%. Now, on the test, you're never going to write negative 25 as an answer. It'll always be phrased in the question like, what's the percent decrease? So we would just say it's a positive 25% decrease. Hopefully that kind of makes sense. It's kind of like, if you instead of saying I gained negative $3, you could say I lost $3, right? So you're almost always in the answer going to phrase it using that positive. So always before you lock in your answer, write down, oh, is it an increase or a decrease? Because if you got an increase when the question is phrased like a decrease, you probably did something wrong, right? Okay, let's do some more practice at the whiteboard. All right. So we're just going to practice doing what we just did. Remember, everybody, the percent change is equal to 100 times the percent multiplier minus 1. Okay, so this 0.17 is just a percent multiplier. So to find the percent change, we're going to do 100 times 0.17 minus 1. Let's see what that gives us. So 100 times 0.17 minus 1. We get negative 83%. And remember, guys, negative percent, that's a decrease. So we're going to say this is an 83% decrease. So if this were a student-produced response, you would just say 83, not negative 83. Because it says the word decrease here. It already accounts for the negative, so you don't need to put two negatives. Okay, great. Let's look at the next one. So 2.49z, same kind of deal. This guy is a percent multiplier. So we're going to do percent change equals 100 times 2.49 minus 1, percent multiplier minus 1. Let's see what we get. 100 times 2.49 minus 1. We get 149%. And it is positive. So we're going to call that a 149% increase, which makes sense based on how the problem is phrased. So we would just put 149 if it were a student-produced response as our answer. All right, same kind of deal here. It wants to know the percent increase from the previous year. So bigger than 1 is an increase, so we don't need to do anything. This is our percent multiplier. So we're going to do percent change equals 100 times 1.95 minus 1. I think I already know what that should give us, but let's just do it at the board anyway. 95%, positive 95%, which is a percent increase. And we're happy with that because the question says increase. So it seems like we did a good job. All right, this last one is really tricky. This has a lot we have to do for words to math. So we have B. Okay, B. Is means equals 8/9 times C. Okay, 8/9 times C. So maybe that would be my percent multiplier, but here's the thing. It wants to know about the value of C kind of as the final, right? And notice how it also says greater. So our multiplier should be bigger than 1, which 8/9 is not. So to fix that, we have to get C by itself. So what we're going to do is we're going to divide both sides by 8/9. When you divide by a fraction, that's the same as multiplying by the reciprocal. So we're going to multiply both sides by 9/8. And we get 9/8b. These guys cancel out. Equals C. And if it's all right, what I'm going to do is I'm going to rewrite this just to make it a little easier to understand. So B times 9/8 equals C. You see this now lines up perfectly with what we were just talking about. Original times percent multiplier equals final. So with C treated as the final, the percent multiplier is 9/8. So that's it. Now we just do what we did before. That was a lot of work, but okay, so now we're going to do the percent change is equal to 100 times 9/8 minus 1. So let's see what that gives us. We get 12.5, so positive 12.5%, which is a 12.5% increase. So for this one, we would put 12.5 as our answer. So as you guys can see, really understanding this guy, but then also being very careful about your words to math and always thinking about the mechanics of what you're doing rather than just doing it in your head makes it so that you can solve questions more easily and you'll be less likely to fall for a trap answer. Okay, let's go back to the board. I think we have one more skill. Okay, last and not least, everyone, we have to talk about how to find the percent change given the original and final values. So we just talked about how to find it given the multiplier. Now we're going to do it given the original and final values. So probably the easiest way to do this is the percent change formula. The percent change formula is percent change equals new minus old divided by old times 100. New minus old divided by old times 100. There's a very helpful mnemonic that might help you remember it. So if you just write the letters at the beginning, it spells out no, like oh no. So percent change equals no. That might help you remember when you're taking your test. So new minus old divided by old times 100. Let's go to the board and do a couple examples. Okay, so for this one, this one is pretty kind to us. Still, let's make a chart just to make sure we're not making a mistake. So I like to make a little chart. And I go, okay, I think the old is 10, and I think the new is 13. So let's put that 10 and 13. Okay, the question wants me to do greater. That's an increase word, right? So let's see, as I go from 10 to 13, is it getting bigger? 10 to 13. Yeah, that's bigger. So I did a good job, right? If I had 13 on the left and 10 on the right, that would be getting smaller, which would be a percent decrease. So you'll probably realize that once you're done, but it's better off if you can kind of save yourself from making that mistake earlier just by making a little chart. So just make sure as you go from old to new that it's getting bigger or smaller depending on what kind of percent change it is, increase or decrease. Okay, so now we're going to do percent change equals new minus old divided by old times 100. So 13 minus 10 over 10 times 100. And guess what? I can just do this all in one go so I don't make a mistake. 13 minus 10 over 10 times 100 really quick. And I get 30%. So this is plus 30%, which is a 30% increase. So our answer for P would be 30. It's 30, P percent greater, 30% greater. Great. All right, let's look at this one. So a lot of times they'll make these questions harder by putting it in like a graph or a table. So I made a little table here. So based on the table, the typical maximum number of petals for flower A is P% less. Okay, so let's make a little chart again. Old and new. Okay, and put a little arrow from old to new. And the typical maximum number of petals for flower A is P% less. So maximum number of petals, that's here. And for A, okay, let's make the old flower A, which is 5. And the new flower B, which is 7. Ah, but there's a problem with what I just did. P% less. Okay, 5 to 7 is getting bigger. Less is a decreasing word. So we're going to swap them. 7 goes on the left. And 5 goes on the right. So old, 7, new, 5. It's getting smaller. P% less. Good. All right. Percent change. New minus old divided by old. Okay. So 5 minus 7 over 7 times 100. And we can go over here and do that in one go. 5 minus 7 over 7 times 100. And 5 or 6 characters. Man, that's going to be a huge pain. I'm just going to remember what I said before and go, wait a minute. I can just use it as a fraction. So I'm going to hit the fraction button. It's negative 200 over 7, which would be an acceptable answer. So it is negative 200 over 7%, which is a decrease. So we're going to write it as a 200 over 7% decrease. And I would put as my final answer 200 over 7, which is fine as long as it's like 5 characters or less, which it is. 5 or 6 characters or less, which it is. Very good. Awesome. All right, I think that's it for these problems. Let's go back to the slides. Okay, everyone. So now we are going to be going over the final review worksheet. I have included a link to this worksheet for free in the description of the video. Please also be on the lookout for a pinned comment which will contain links to other places where you can practice these skills even more so you can get even better at it beyond just doing the 10 or 20 problems that's on my worksheet. So please, 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 now would be a great time for you to download that worksheet from the description and do it yourself before watching the rest of the video. Okay, let's get started with the worksheet solutions. Okay, time for the final review. So 25% of 168. So we're going to do divide by 100. Change the of to multiplication. Divide by 100. Change the of to multiplication. Of course, we could also straight up type in 25% and it'll put of. But like I said many times, I recommend you do it the old-fashioned way so that you remember the mechanics for when you come across harder problems. So the answer to this guy is 42. Question 2, what is 230% of 54? Okay, so we are once again going to divide by 100, change the of to multiplication, and let's see what we get. 230 divided by 100 times 54. We get 124.2. All right, let's look at this one. 30% were dimes. How many of the coins were dimes? Okay, so it basically wants us to find 30% of 250. So we're going to do 30 over 100 times 250. And let's see what that gives us. 30 over 100 times 250. That gives us 75. So 75 of the coins were dimes. What fraction of the shirts are purple? What percentage of the shirts are purple? Okay, so the fraction, part over whole. So 7/16. That's already simplified, so that would be fine as a final answer. You could also leave it as a decimal, especially if the decimal comes out nicely. All right, let's see the percentage. Part over whole times 100. Part over whole times 100. That's one of the things we talked about earlier in the video. So we're going to do 7/16 times 100. Once again, not going to do that in my head. We get 43.75%. Very good. Okay, for this one, we're going to do is over of equals percent over 100. Next to the percent is P. Next to is 45. And next to of is 160. So I'm going to put that here. Now I'm going to cross multiply. And we get 4,500 equals 160p. Now I'm going to divide both sides by 160. Get P equals 28.125. Okay, great. All right, this next one is the same. 60% of x. So we're going to do is over of. So 60 over 100 equals, next to is 315. And next to of is x. So we get 315 times 100. What is that? 31,500 equals 60x. Cross multiply. And now we divide both sides by 60. And we get x equals 525. Okay, percent multipliers. For an increase, 1 plus percent divided by 100. For a decrease, 1 minus percent divided by 100. So let's rapid fire all these guys. Increase, 1 plus 25 over 100. That's 1.25. Decrease, 1 minus 41 divided by 100. That's 0.59. 593% increase. Okay, 1 plus 593 over 100. That's 6.93. Increase, 1 plus 0.3 over 100. That's 1.003. And 2.6% decrease. So that's 1 minus 2.6 divided by 100, which is 0.974. All right, very good. Okay, population of a town was 430,000. Okay, so see how it says the word thousand? And then I'm going to check to see if it says in thousands in the answer. It does say in thousands, so I don't need to multiply by 1,000. I just leave it as is. If it didn't say in thousands, you'd have to make sure to write 430,000 at the beginning, because the answer, the units need to match the answer. So anyway, so just be careful of that. All right, so we're going to do, for a bunch of these, original times percent multipliers equals the final. And we're starting with 430 and then applying a percent. So that's going to be our original. And it says grew by 30%, 70%. That's not one of the words we did, but grew means to get bigger. So that's a percent increasing word. So let's find the multiplier for a 70% increase. 1 plus 70 over 100. It's 1.7. So we're going to do 430 times 1.7. And that'll give us our final, which is in 2016. So 430 times 1.7 is 731. And I don't have to put 000 because it says in thousands. Great. Okay, same kind of deal with this one. So the final, we don't know. We want to find what is the result. So we can call that x. The original is 784. And we're doing a 52% decrease. So let's see what a 52% decrease is. 1 minus 52 over 100. That's 0.48. So we're going to do 0.48. And I don't have to do any algebra because x is already by itself. That's nice. And I get 376.32. All right. Okay, original times percent multipliers equals final. Okay, so the original price of the video game, we don't know. So we're going to put X. Then we have a 20% off coupon. That's a decrease. 6% sales tax. That's an increase. Let's figure out both of those. So 1 minus 20 over 100. And then 1 plus, because sales tax is an increase, 6 over 100. 0.8 and 1.06. All right, and remember, when we have more than one, we just put them next to each other. We stack them. We don't like add them or anything like that. You just put them next to each other. And the final price is what he paid at the register, which is $42. Okay, and now we're going to divide both sides by 0.8 times 1.06. And this whole guy goes away. And we get x equals 42 divided by 0.8 times 1.06. And let's see what we get. So 42 divided by 0.8, 1.06. And we round money to the hundredths. Question doesn't say, but we round money to the hundredths, so this would be 49.528, so 49.53. So this would be $49.53. Now, when you do a question like this, it might be wise to go back and plug it back into kind of the beginning and see if you get what they told you to get, 42. So why don't we do that really quickly just to make sure we did it right. So 49, and because we rounded, it's going to be a little off, but that's okay. 53 times 0.8 times 1.06. And we do get, just because we rounded, we do get just about $42. So that means we did a good job. Stupendous. All right, let's keep going. All right, this guy is a percent multiplier. It's less than 1, so I bet it's asking me to find a decrease. The question is, so we can do percent change equals 100 times percent multiplier minus 1. So we're going to do percent change equals 100 times 0.26 minus 1. Okay, let's see what that gives us. So negative 74. Okay, so that's negative 74%. And we don't put the negative because we just phrase that as a 74% decrease, which is what they wanted us to phrase it as. So the answer to this one would just be 74. All right, same thing with number 12. We got a multiplier, and this guy is bigger than 1, so I bet it's asking me for an increase. It is. And we have to find the value of p, so we're going to do percent change equals 100 times 6.82 minus 1. So 100 times 6.82 minus 1. That's 582% positive, which is a 582% increase, which is what the question wants us to put. So our final answer would just be 582. Okay, these guys are percent change formula, so don't forget, no times 100. So based on the table, the typical minimum number of petals for flower B. Okay, so we're looking at the minimum, and it says more. Okay, so the bigger number should go on the right side of my table. So flower B is 4, so that should go on the right. And flower A is 2. Okay, if I go from 2 to 4, am I getting bigger? Yes, I am. All right, so percent change is 4 minus 2 over 2 times 100. Okay, I think I know what that is, but let's just do it anyway. So 4 minus 2 over 2 times 100. And we get 100. So this is a 100, positive 100% change. Which is a 100% positive is an increase. Okay, so now we're looking at the lifespan. So let's look at the lifespan. That's this. It says p% less. Okay, so I bet my smaller number should be my new. So the smaller number is 10. No, it's 6. So we're going to put 6 over here and 10 over here. Double check as I go from 10 to 6. Do I get smaller? Yes, I do. All right, so let's do percent change equals 6 minus 10 new minus old over old times 100. 6 minus 10 over 10. And we get negative 40. So this is negative 40%, which is a 40% decrease, less is a decrease word, so we would just put 40 as the answer. Okay, I think we've got one or two more. Great. A certain country had a child population of 35 million people. The child population was 40% of the total population. What is the total population in millions of people? Okay, there's a couple ways we could do this. We could do a percent of, or we could do part over whole. I'm going to do part over whole. So, part over whole equals percent divided by 100. And so the part is 35 million. It says in millions, so we don't need to change it. The whole is the total. We don't know that. X. And then the percent is 40 over 100. So we're going to do 3,500 equals 40x. Divide both sides by 40. We should get 87.5 million. Okay, very good. And you could again double check it, 40% of. So 0.4 times 87.5, and we get 35. So that works. All right, I think this is our last one. So the final price of an item. Okay, so original. Okay, so the final price of an item is X. Okay, so let's put X where final goes. We want to find the original price. I'll just put original. And now we got to do the percent multiplier. So we have a 35% off coupon and a 7% sales tax. So 35% off coupon, that's 1 minus 35 divided by 100. And then 7% sales tax, we add because it's an increase. 1 plus 7 over 100. We get 0.65 and 1.07. Okay, right away, even if you didn't even do the problem, these two guys are looking to be wrong, right? They don't have the right multiplier. So they're probably not the right answer. Okay, so remember it says in terms of. So the thing in front is what we want to get by itself, the original price. So to get the original price by itself, we're going to divide both sides by 0.65 times 1.07. This guy goes away, and we get original equals X over 0.65 times 1.07. I'm not going to type that in the calculator because the SAT has a tendency of just leaving things kind of just in its place like that. And as you can see, we did do that on this answer. Answer choice C, X over 0.65 times 1.07. Okay, very good. All right, I think that's it for the review worksheet. Let's go back to the slides. Okay, everyone, thank you so much for watching. Please do not forget that I will have a pinned comment with links to more helpful resources about the topic of this video, percents. Please be sure to check that out. And also, please like and subscribe for more digital SAT math content. If you are interested in my tutoring services, the link to my website will be in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.